So my name is Armaan Sharma, and I'm presenting on the synergistic studies of sulforaphane and cephalotaxine as an agent. So just like some background. So I mean this is sulforaphane is a protein found in cruciferous vegetables, such as broccoli and cauliflower, and it has like there has been some studies about like how to use it as an anti-cancer agent, but nothing really there hasn't been like any major things. Cephalotaxine is an FDA like anti-cancer drug, and there's like much more research on that. So our project, or what we wanted to see is if we can if we can use the two together, like, and find like synergistically how they work to combat cancer. So I think most of you know that cancer is the abnormal growth of mutated cell growth of mutated cells with the capability spreading throughout the body, and the disease is a major cause of deaths worldwide, about 10 million deaths per year. And so in doing this, we hope that we can like conduct research and have findings that are able to combat this very harmful disease. So what we have done is we've worked with C. elegans, two different strains of these worms, the TJ375 and JK1466. And we have conducted assays on them using different concentrations of cephalotaxine and sulforaphane to see the absorption levels in the C. elegans and see what that and then draw extrapolate results from that. Okay, I've kind of already gone over like the introduction, so we'll just I'll just go on to the methodology. So in this we use potassium phosphate and disodium phosphate, sodium chloride, and magnesium sulfate, and we add water to that to create the M9 buffer to culture the C. elegans. And this is part of the process of synchronizing the worms. And this is really important to do because if we don't like age synchronize them, there's going to be a very big margin of error in our results. So that's what the M9 buffer is for. And then we basically, in order to make the LB broth, strain, we added bactotrypton, yeast extract, and sodium chloride to distilled water and autoclaved it. And then we inoculated the broth with a single colony of OP50 E. coli from the culture plate under sterile conditions, and it was grown overnight at room temperature. And then we have to do like we have to seed the plates. So we dispense 100 to 120 microliters of the OP50 onto the plates, and then we have to make the NGM for the worms to settle in. So what you do is you add like agar, tryptone, and potassium phosphate in deionized water, and you have to mix that like really well with a magnetic spin bar, and then autoclave it, and then you put the NGM solution onto the plates, and then you inoculate that with the OP50, and then you can grow the worms on that. For the MTT assay, which basically like measures the absorption level and metabolic rates of the worms, we use the strain, the JK1466 strain, because those were the ones that survived better. So yeah. So then once we finish the age synchronization process and we put different solutions of the cephalotaxine and sulforaphane in the microteacher plate, we had a few results. So after conducting the MTT assay, we were able to receive performed with the JK1446 worms, we were able to determine the viability of C. elegans after drug treatment. So we tested one sample without the drug to act as a control for this assay, obviously. And then our C. elegans concentrations for the JK1446 strain was around 3 to 5 worms per microliter. And within the first hour of adding the MTT, our values from the spectrometer were around 0.5 for the control, around 1.5 for the A1 sample, and around 1.9 for the B1 sample. The solution in the whorls of the microtiter plate were yellow in color. After a day of incubation, we tested for absorption values again and got around 0.7 for the control, around 1.6 for the A1 sample, and around 2.1 for the B1 sample. And these wells were purple in color, and we were able to assess that the absorbance signal is proportional to the amount of worms. As the longer the incubation, the more worms present. So this means that there were more C. elegans to absorb the MTT, resulting in a slightly higher value. But this was just a trial, so we hope to conduct this assay again in the future for better results multiple times, and then use that research. So as a conclusion, cancer is unregulated cell division. It's very harmful and an invasive disease. And right now there's no cure for cancer, but the more treatments, the better. And this is why we're trying to use cephalotaxine, this anti-cancer drug, and sulforaphane, this like experimental protein in broccoli, and see the synergistic effects on the C. elegans with that. We also hope to use HCT116 cells in the future, which are cells found in the male colon cancer lining, to see how it affects actual human cells. So these are just some pictures of the process. You can just read like the subtitles. And then we would like to thank our advisor, Ms. Ranganathan, ASDRP, the Olive Children's Foundation, University of Minnesota, and the American Cancer Society for all the work and help that they've put in. And yeah, that's about it. Thank you.